started. Good. First of all, well, short presentation for me, but I guess most of you already know me. So I'm basically a software developer. I'm not working currently at Amdaris anymore. I switched to Avelgo, but I'm also the founder of Code Wrinkles and the co-organizer of the Apex Vox conference. And I also have a blog on which I used to write fairly often, but during the last months I didn't manage to write something new. But my plan is also to start again writing on my blog on a fairly consistent basis. So let's see what we are gonna look at today. First of all, we have an overview of what Blazor is, and then we'll go into three different aspects of how we architect or how we design our Blazor application, following some patterns or principles that we are accustomed from Angular. So we'll talk about folder structure, we'll talk about designing Blazor components, and we'll talk about component communication. And throughout this presentation, I will also show some code samples, of course, and I hope that everything will work fine. Let's then get started. So first of all, what is Blazor? Well, simply told, Blazor is a framework in .NET, of course, for building interactive client-side web UIs. What does this actually mean? Well, it basically means that Blazor enables us to write applications that feel like Angular application, like single-page application. And this is because in this scenario, Blazor is basically shipped to the client, although there are two different hosting models that we'll talk about very, very soon. But generally speaking, in this Blazor framework, all the code that we write, so all our DLLs, are shipped to the browser, and everything we do in that application is basically done in the browser itself without communicating to the server at all. So this allows us basically to do right now single page applications using .NET and C#, which is, from my perspective, very, very cool. Then I told you that there are basically two different hosting models in Blazor, and there are some differences about them. So first of all, we have this Blazor WebAssembly, which is the fully client-side Blazor. And in this hosting model is basically where we ship all the DLL, so all our files or all our compiled C# code, we send it to the browser, and everything is executed within the browser, because everything that we need to execute the application and everything around is basically already there. However, this Blazor WebAssembly, or the client-side Blazor, is right now not fully supported, so it's not globally available. It's in the .NET 5 preview right now, so this means that by the time that .NET 5 will get into global availability, also Blazor WebAssembly or client-side Blazor will be fully supported. So from that point on, you can basically write applications that are shipped to the browser and executed from there. Then the second hosting model is what we call the Blazor server. And the cool thing about this is that, okay, right now we cannot simply ship our DLLs to the browser due to some different very, very important reasons, like download sizes, lazy loading that is not available yet, and so on. But the programming model is very, very interesting and new, because it allows you to write really full stack applications in C#, including the front end. So in this case, the Blazor team thought, what if we don't ship the DLLs to the browser, but what if we simply create a signal R connection, so a WebSocket connection, through which the UI communicates with the server. What this actually means is that your applications is hosted on the server, so nothing is sent to the browser except some HTML files. And instead, whenever you click a button in the UI, or whenever you perform any type of action in the UI, what it does, it connects back to the server through that WebSocket, and it asks for differential HTML. So if, for instance, I click a counter button, the counter is right now set to 1. When I click the button, through this WebSocket, the frontend communicates with the backend and says, hey, that button was clicked. So on the server side, Blazor computes basically the diff in the HTML that is needed, or the update that has been done by clicking on that button, and then that update is then displayed in the UI. What this means from a user experience is that users will have the same look and feel like a normal single page application. So whenever you click on a button, whenever you navigate through the Blazor application, basically it never reloads, which is very, very important. And the good thing about Blazor Server is that it is fully supported. It is globally available together with .NET Core 3.1. So this means that basically right now, if you start up a new application or want to build a new application, even for a customer, like a production application, it is fully supported to use this Blazor Server hosting model. Now, let's get one step further. And the first aspect that we will talk about here, comparing to how we do things in front-end development in Angular, is folder structure. And here we have a very interesting thing to note, I guess, because when it comes to how we organize our code base, or how do we organize our files and folders, this is a very important aspect, and there might be different approaches depending on, let's say, the environment that we are normally used to work with. And when it comes to folder structure, there are basically these two different approaches. One is this convention-based approach, and the other is that feature-based approach. Let's take them one by one. So convention-based approach is the one that follows the strict naming conventions, or I would say that this is the approach that we are used in the .NET ecosystem when we develop normal MVC applications, either APIs or also applications that contain some razor views and so on. In this case, we are very accustomed to organize our code by having like a folder that is called controllers, and in that folder we put all the controllers. Of course, we might have different subfolders, but usually in the controllers folder we have all the controllers. Then we have a folder, I don't know, called services maybe, and in that folder we put all the services. Once again, probably with also some subfolders, but generally all the services go there. So this means that we basically create folders that gather together classes that do a certain type of thing, I would say. However, what this means is that it could be very difficult to find something that you are looking for because you don't know exactly in which folder to look. For instance, if somebody reports a bug that when you click a button, the wrong information is displayed, then what you have to do basically is to go and try to find out, okay, but where are those code lines, where is the method that basically has an error or returns information that we don't consider as valid. And in that case, you will have to follow basically the entire flow from the controller. So you will check in the controller if everything is there, or if everything there is correct. Then you will check all the services that you have injected in this controller. Then maybe we'll check the UI and so on. And you never know exactly where the problem might be. Then there is the other approach, which is the feature-based approach, which is also the, I would say, officially recommended approach by Angular, because you can find it also in the Angular style guide. And in this case, you organize your folders by features. Let's assume we have an application that is something like an online shop. Then we will have something like, I don't know, a shopping cart. So this would be a feature maybe. And in this case, we would create a folder, which is the shopping cart. And in that folder, we will put basically all the classes that we need for that feature. So it could be that if we need a controller for the shopping cart, we put a shopping cart controller. If we need a pricing service for the shopping cart, then we put that pricing service there. And if we're talking about services, there are some differences, and we will come to this just a little bit later, because there are services that are, I would say, strictly related to one feature, and those services would be put in that folder. But there are services that might be used throughout the application. In that case, we would handle this, of course, separately. But I think you get the idea. So you have one folder that defines also the feature, and in that folder you basically put everything that you need, the models that you need, the controller that you need, the services that you need, and whatever other classes that you need. Everything that is related to that specific feature is placed in that folder. The good thing about this is that you can easily find a let's say, or it's easier to find a problem when something is reported to you. Because if somebody says, I have a problem with the shopping cart, then you already know if I go to my application, there is the folder that is called shopping cart, and somewhere in that folder, there has to be that problem. So it's easier to find the code here. Now, of course, you might ask, what is the correct approach? And as it often occurs in programming, there is not really a correct way. It really depends on what you want to do, on what you want to achieve. It depends on the type of the application that you are building, basically. Because if you have some feature-rich applications, like heavy UIs with a lot of different components there, then it would be, of course, better to organize the code by features. But if you have applications that are not that feature-rich, then and if you are accustomed with the convention-based approach, then I would also suggest going for the convention-based approach. However, no matter which approach you want to follow, there is one very important thing, is to keep the flattest possible folder structure. Because if you have a very deeply nested folder structure, it brings a lot of problems, and it makes it difficult to really find whatever you are looking for. So again, it's important to keep the flattest folder structure possible. However, since I think that for feature-rich applications and Blazor applications, which are essentially single-page applications, they are normally very feature-rich, I would suggest for Blazor having this feature-based approach. Now, besides these feature-based folders, like I said, we have a feature called shopping cart, and we have a folder called shopping cart. But there are two very important folders in Angular best practices and patterns, which are the core folder and the shared folder. And the core folder is very important because it usually contains services that are shared throughout the entire application. And the same applies also for Blazor in our case. So we will have a core folder, and in that core folder, we would put all the applications or all the services that we need throughout the application, or mostly, or throughout most of the application. And some examples for it, we have services like logging services, error service, data service, app state service, which in Blazor is very important, because this is the type of service that you would use to keep track of the state of the application and to any changes in the state of that application. But you get the idea. So this means that I would also suggest that in Blazor, so when you are creating a Blazor app, that you would also have this core folder in which you put all the services that you need throughout your entire application. Then the other very important folder is the so-called shared folder or common folder. And in Angular, this folder usually contains non-routed components. So this means that components like buttons, like layouts, like drop-downs that you would use throughout the application at some point, but for which you don't need any routes to point at. So these components are usually placed in this shared folder. And this is also an approach that we could use for Blazor, because in Blazor we will also have a lot of different Blazor components, and we'll come shortly to Blazor components that are basically non-routable. So we won't have any routes that would, let's say, lead us to that component, but that are used throughout the applications, like navigation menus, like buttons, like drop-downs, whatever, exactly like in Angular. The only difference is that in this case the components contain basically or are defined by a markup or the Razor part and the C# part, so the logic behind them. But we will come to this just a little bit later. So let's see exactly how this would look like in a Blazor application. And here I have Visual Studio with a Blazor application. It is basically or essentially a server-side Blazor application that I have created for demo purposes, but the application itself is working. We can even run this to check if it's working correctly. So let's open a browser window, and let's switch to this one. Okay, so it's basically loading right now. But what this application does, it would connect via the GitHub API to my GitHub account, and from here I'm basically, for instance, I can go to my repos, and then here I can see a list of the repos that I have. And for instance, if I search for a certain repo that I know has also some issues in it, but I cannot seem to find it right here, this one. Here I'm routed to a different component where we have this type of branches. So we see the branches that we have in this repository, and then the issues that we have in this repository, together with information like who the author of the issue is, who the issue is assigned to, and so on. For now, this is mostly all the implemented functionality in this application, but I think you get a short idea about what this really means. Now, coming back to Visual Studio, I wanted to show you exactly how my folder structure looks like here in this GitHub dashboard web application, which is a Blazor server application. So we have, first of all, we have this core folder, and in this core folder I have two services. I have an app state service, which is used in Blazor to keep track of the state of the application so that we can react to changes in the state. Here we are doing also a bunch of stuff, like when we log in, we write some information to local storage so that we can persist the login. We read some information from the local storage, and so on. And then of course we kept track about if the user is logged in, the GitHub token, and we have the user, the GitHub user, and of course we have then methods for login, we have methods for logout, and we have here this check if authenticated, and so on. I won't dive deeper into these methods because it's not important really what I have implemented there. And then there is another service that I would use throughout the application, and which is this GitHub API client. And this service is basically using the HTTP client factory to inject an HTTP client to configure it, and I use this HTTP client, this GitHub API client, to call the GitHub APIs that I need. And here we have, for instance, a method for login. We have get my repositories, which would retrieve the list of the repositories. This method is eventually used somewhere where we get the list of the repositories and display it on the UI. We have then get repository by ID, so where we get a single repository, and so on. But I guess you get the idea. These are services that I will probably use throughout most of the application. So wherever I will create new components, I will most probably also have to talk to GitHub, and for that I would use this GitHub API client. And this is why I put this service in this core folder. Then I have a folder called features, and in this folder we can see that we have different folders depending on the features that we are looking at. We have first the login feature, which here we have a post model folder for the login feature, which is the client ID and client secret. Here I didn't respect the naming conventions because I had to have them exactly like that in order to simply match them to what GitHub expects from me. I'm aware that we could do this well in a more elegant way, I would say, but for simplicity I simply named here these properties according to what GitHub expects from me to send there. We have a login model that is basically used for the component, for the login component. We have this login razor, which is the login part of the component. So you see here this is the markup, and then we have the GitHub token response, which is basically a class that will contain the GitHub token after I have done the authentication. Then you see that I have a profile folder, but in this folder I didn't create for now that much functionality. Then we have this repositories feature, and this is the main feature right now in this application. And here we have, first of all, two, I would say, sub features, which are my repos. And here there is the razor part of the repository, so where you get the entire list of repositories. Then we have the report details, and this is the part where you can simply check the branches and the issues for each repository. And then we have this shared folder, and in this shared folder, for right now, I placed two components, which is the sidebar with the markup with the razor part, and then the sidebar model, which contains the code behind, I would say. Then we have this nav menu. Once again, we have this markup, and then we have the code behind. So these are basically Blazor components, but to components we will come just in a while. So let's get back to the PowerPoint right now. Okay, so we have looked into this. We see right now, we've seen how a folder structure, a very simple one, might look like in a Blazor application. So let's go then one step further and have a talk about Blazor components, because components are really the vital part in Blazor, just like components are the vital part in Angular. And when it comes to design Blazor components, we have basically three types or three different ways through which we could use or design our components. And the first way we could do this is by create inline components. Now, inline components are basically or are contained in just one single file that has a .razor extension. What this means, it means that in that single file we put both the markup or the razor part, and we put also the code behind. The markup is very simple, like really a razor markup that we can define there. And then if we use this code directive previously or in earlier Blazor versions called function, or the directive that we used was functions, in this code directive we can then put all the code that we need. So the C# code, which could be, I don't know, properties, methods, and so on. Now, the good part about this is that you have on one hand both the markup and the code behind really in the same file. But however, this is also a big disadvantage, because when you have like production ready components, you usually noticed or know that they contain a lot of HTML. So this means that you have, I don't know, 1,000 lines maybe of HTML, let's say. That's, I would guess, an exaggeration, because if we would have such files, then I would split them basically, or maybe in sub components. But if we have these 1,000 lines of HTML, and then at the end of those 1,000 lines we have another 500 lines of C# code in this code directive, then of course it's very difficult to find something there. So again, this type of defining a component might be useful in very easy components, or very simple components where you have just a few lines of markup and just a few lines of C# code. Then the second way to do this is by using the so-called code behind components. And these are components for which we basically split the markup and the C# part into two different files. Of course, then we will have to bind them together, and to do this we use this inherits directive. And we will also look in code just in a few seconds to see exactly how or what this really means. Just as a convention for earlier Blazor versions is that in this case, so if you did this in earlier versions, you couldn't name the razor file and the C# class the same way. So if I have like home, I cannot name home both my razor file and my component. And in this case, we would have to use different type of namings, and then just use like home.razor.cs. And in that case, it would have it would have known that okay, we can use this class as a code behind class for this specific component. And the third way to design components, which I never did, and I guess nobody would ever do that, is by simply defining a class. How this basically works is that Blazor, what it does behind, when it compiles everything, so your markup files with your code behind files, Blazor basically creates a class that inherits from this component base, and it has this method which is build render tree, and it simply builds the tree of the application or the HTML that should be displayed in the browser. You can also think about it like a shadow DOM, like a shadow document object model. But this shadow document object model is nothing else than using this builder and add different elements to it in a certain order, and then we can add some sub elements and so on. So purely theoretically, we can define Blazor components only by using C# code. But to design even I would say fairly simple component using this type of component design would be really huge overhead, and we would probably do something wrong. So I wouldn't suggest that we even try to do such or to create such components. Okay, so my suggestion is to use the code behind components. First of all, because in this case we split the markup and the C# code into two different files, and the way I see this is like a separation of concern at the level of the application folders, I would say. So I would just like to have separated my markup from my logic. It's just easier to follow or to look for things. Then class components, as I said, they are very verbose and they are really hard to read, and it's very easy to mess up. So this is why I wouldn't suggest to use this class components, and therefore the only type of component that is really suitable and I would say scalable for larger applications is to use this this code behind the components. And we'll also have a brief look at how these components look like. Just 1 second. No, okay, it doesn't seem that I have any questions here. So let me then switch to Visual Studio once again, and I hope that you can still hear what I say. Here, for instance, let me go to some components here, and here I have, for instance, this repository component, and here I have this my repos component. And if we expand this structure here, we see that we have a myrepos.razor file, which contains basically Razor syntax to display a list of repositories. And then I have then a C# class which is called myrepos.razor.cs. And what we see here is that in this code behind class of the component, I have to inherit from a component base. This is a very important thing. So this is when you create a class, this is how you make it be a component class. You make it inherit from a component base. Then we use the inject attribute to inject the required services, which in my case is this app state service and the GitHub API client. And then we have, I override this on initialized async method, which is basically a method from this component based class. It's a virtual method that I can override. And here basically what I do is I use the API client and I get my repositories. And of course that I will use them then to put them in this property, which is of type list of repository and so on. So not a really big logic here behind, but it's important that everything that it happens behind it is handled throughout C# methods and properties and classes, whatever is put in this component. And then if I go here to the markup part, we see here this directive inherits. So this is the way that we basically say, okay, for this markup file, for this Razor file, we have a code behind file, and it is this one. So if I go here, you see that those two are bound together. And this is the way basically that you create such components. In this case, this component is also a routable component. This is why we have this page directive. and I say that whenever somebody navigates to my repos or the root of the application in my repos, then this component should be displayed. It's exactly what happens or what happened when we clicked on that my repos button. Basically, it displayed this component. So that's basically it, how you create this code behind components. Let's then switch back to the presentation. Or let me also check if we have anything in the chat. No, it seems that the chat is empty, or maybe am I wrong? No, I'm not wrong. The chat seems to be empty right now. Okay, so let's go further. In this code behind components, we saw how they work. Let's go one step further, and let's see how we can communicate through these components. And here, basically, when it comes to component communication, we have two different scenarios, and this happens also in Angular. In this presentation, I cover only one of the scenarios, but I will also briefly talk about the other scenario. And the first scenario, when it comes to component communication, is of course, how can I communicate from a parent component to a child component? This means that we have a scenario in which, let's say, we have a hierarchical order of the components. So we have a parent component. To that parent component, we have a child component. The child component can have another child component, and so on. And we need ways to communicate throughout this entire hierarchy of components. And we have in Angular ways to do that, and we have very similar ways to do this also in Blazor, and we'll look into that. But then there is also the second type of component communication, in which we want to communicate information between components that are not in a relationship. So we have maybe some button on the nav menu in which we display the number of messages, let's say, but that component is really not the child component of another component that really gets the messages. So in this case, we will have to communicate this information throughout a different mechanism. And this is, for instance, where this app state service could come in, which means that if you click on a certain button and something happens, then the app state will change, and then each component can listen to the changes that happen to that app state and then display the updated information accordingly. This is why this app state service is very, very important in Blazor. And let's go back to focusing on this first scenario, where we have this component, which is a parent, and we have a child component. In this case, basically, we use to communicate information from the parent component to the child component using the parameter attribute. And in this case, it basically it means that you can simply send information from a parent component to another child component. And if you're familiar with Angular, you can think about this like input properties in an Angular application. The way these parameters work is exactly the same. The only major difference, I would say, is here you are explicitly using an attribute in C# to define that, okay, here for this property, it serves as a parameter for some data that will eventually come in from a parent component. And here we have also in this screenshot some basic example of this. Then we have the second part, where we have to communicate information from the child component to the parent component, because sometimes we might interact with a child component, and then this interaction needs to be, well, sent in some way also to the parent component. And in this case, we have in Blazor what we call event callbacks. And in this case, we can simply define such callbacks that can be triggered when something happens on the child component, and then the parent component will know that specific action happens there, and then in the parent component we can do, or we can implement the necessary logic to handle that specific type of action or event that happened. And this is very important if we come to a new, or if we come to discuss about this pattern, which is very popular in Angular, which is called the container presentation pattern. And in this container presentation pattern, we have basically two types of components. We have the container component, or the parent component, and this component is responsible for handling the data retrieval or data update, and everything that is needed or everything that has to do with data is handled by this container component. And we have the presentation components, which are merely there to present the data. They won't interact with services at all. They will simply present data. And we can also use this type of container presentation also in Blazor. And let me switch back to Visual Studio to see exactly how we can do this. So let's go back to Visual Studio. And I guess you should be right now able to see my Visual Studio, and I guess yes, it should be there. So in this case, we are still here in this my repos, but we will look at this repo details, because this is a place where we have defined this container presentation pattern. And we have here the first component, which is this repo branches, and if we expand this, we see that we have also a code behind. But then we have this repo details and repo issues. So if we take a look in this report branches, we can see that this component from a markup perspective is, I would say, a very, very small one. What it does, it simply iterates through all or to a certain repository to get all the information from there. In this case, it gets the information regarding branches. Then we have this repo details, and we see that in this repo details, this component is a slightly bigger one. But what happens here is that you see here we have at a certain point repo branches. So this is basically, this refers to my repo branches, which is this one. And we'll see that here we see at work also how this I would say input parameters work here. So let's go back on repo details. So we have first we use this branches component or repo branches component, which is a child component, and then we have this repo issues component, which is also a child component, and it refers to this one. Now this is the markup for the issues. Now let's go to the parent component, which is this repo details, and let's look at the code behind. So we see that in this repo details, first of all, we have here some name that we receive basically from the routing part when we click on a certain repo, and we inject these services, this app state service and this GitHub API client. And why I want to emphasize this GitHub API client service is because this is the service in my case that handles data retrieval, data updates, and so on. So in this component, which is the parent component, I inject this GitHub API client service, and I use it throughout the service to perform different operations, to get the branches, to get the issues, and so on. However, if I go to repo branches, we see that in this class, we basically have only this incoming parameter, which is in this case this list of branch. And here I have injected also the GitHub API client, and I have forgotten to delete this. We can even delete this and this application would still work. But the idea is that even if I inject them, I don't use them. So basically in this component, this is a presentation component, a child component. If I need to perform anything on the data, or if something happens, I would simply notify the parent component or the container component, and that component will then handle data retrieval. So again, once again, we just have here this incoming parameter, which is called branches. And if we go to repo details, we will see exactly how this is defined. So we hit repo branches, and then we have branches. This is the property that I have defined, and it simply puts in here a list of branches. And then similarly we have for issues, where if you go to issues, so if you go to issues, we see that we have this input parameter, which is issues, and this in the parent component, we simply use it and pass in a list of issues. So this is how we do this container presentation pattern in Blazor. Once again, that we see in this parent component, which is repo details, we retrieve all the information. So we will have a list of branches and we will have a list of issues. And then when we want to navigate to a child component, we simply use that component and pass in the branches, the list of branches, and pass in the list of issues. So this is how we achieve this component presentation or a container presentation pattern in Blazor. Let's switch back now to the PowerPoint and get one step further, because the good news is that we are almost already done. So let's go one step further. An important part of the application, as said, is this state container. This is very important for Blazor apps because you need to keep track of the app state. And of course, you need to, in the application, you need to react to changes in the application state. Of course, there are different approaches to that, and my plan is to do a really deeper session or deeper streams or videos about state containers in Blazor, because you can have something very simple like an app state service like I have, but you could even develop by yourself a more complex service. I would think about something similar to NGRX, but for Blazor and written in .NET. So you could really accomplish very complex scenario using this state container service that once again you would have to define by yourself and keep track of changes by yourself and react to changes by yourself in the code that you're writing. So that would be mostly it for this first stream. I hope that there were some interesting topics here. Once again, this was only a test. I just wanted to test out how things work with live stream, if I'm able to live stream, how the quality of the stream is, and so on. And the next stream would be the real one, I would say. It will start on Wednesday at 7 p.m. Time in Romania, so Eastern European time. And once again, for that stream, or what I plan to do right there is to build together with you a social media application, web application from scratch, using domain-driven design patterns and principles. And this is a really good learning opportunity, both for me and I guess also for you. I already worked on a similar application, social media application using domain-driven design. And I think that there are some valuable aspects and things that we could go through together. Once again, I always count on you to write some questions in the chat and also to get engaged in the chat. I don't want you to look at this stream like something that you only listen. I really want you to ask questions, to say things. If you see that I'm doing something wrong, then just correct me. I'm not the one that really knows everything. It could be that during the streams I might very well Google some things. But the important things, or the important thing that I will emphasize, is that I really want to build a community here, a community in which we can learn together, in which we can grow together, and then maybe share our knowledge, not only me, but also you, to other people, to other colleagues, to other peers. And this is the way that we will get basically the .NET community go bigger, stronger, and more knowledgeable. Thank you once again for watching this stream. I'm very glad you were there. And I hope to get you here once again on Wednesday when we start the social network stream. So have a nice day.